Okay, welcome to this recording about Python. In this one we're going to introduce a new data type called lists, and we're going to look at how to use them. So far we've looked at integers and strings and floats and bools. We discovered they're all immutable types, it means we can't change them. We've tried to explain what that means. We're now going to look at lists. Lists are our first type of data that are what we call collections. Python has a number of collections of types of data, and lists is the one we're going to look at. If you've done other programming languages before, you may have come across these and called them arrays. Lists are very similar, but they're much more flexible in Python. So lists are quite clever in the way they work and do a couple of unusual things because, as we'll discover, they are mutable. So let's get on with the presentation. So where might you use lists? So imagine you had a number of pupils in a class, or a number of items that you wanted to put onto a shopping list, or a collection of people's height sizes. Whatever it is, if it's information that's more than a single item, then generally if we were writing this down, we would write it down as a list. We'd physically write it down on a piece of paper as a list, that's what I mean. Now when we come to try and store that inside the computer, we know about variables and we know about string variables, so we might be tempted to do what we've shown here, which is create a variable called pupil underscore 01 and give that to George, and underscore 02 to Ahmed, 3 to Frida, and so on all the way up to underscore 30 for Zeta. What we've done there is we've created 30 separate variables, one for each student in our class. That in itself is not necessarily a bad thing, but if I wanted to print out all 30 students, I'd have to write a print statement with all 30 variables in that statement. So I'd have to print pupil 01, then pupil 02, pupil 03, because the number 01, 02, 03 are not numeric, they are just strings put on the end of the pupil variable name. So they're just individual variables and there's not a lot I can do with them. What I really want to be able to do is really talk about a generic pupil, pupil X, and I want to be able to vary that value X so I can talk about the third pupil being Frida or the 10th pupil being whoever. So I need a new kind of construct, and that's what these list constructs gives me. It gives me the way to control these sorts of data and what we call index them. So what do? Well, we create this list type. Out of interest, in Python we can actually mix the type of data in a list. In our example there, all the items in our list were names of students, but Python is incredibly flexible, and in your list you can put anything you want. You can put names and numbers, floating points, bools. In fact, you can put other lists as items in lists. So what's the syntax? Well, when we create a list, we always create the list with square brackets. So you can see there we've got pupils is equal to, and then we've got an open and closed square bracket, and we've got 4 strings in there for 4 people's names, and they are separated by commas. And the commas are crucial. The commas separate the items in the list. So we've got the string George, the string Ahmed, the string Frida, and the string Zeta. So our list of pupils is has 4 items in it. The name pupils then becomes our variable name, and the list is called pupils. Yeah, because I put an S on the end of it there, but of course you can call it what you want. Just for interest there, I've just shown we might create another list called person, and in this person list we might have information about a person. The first item in the list might be their name, so Bill. The second item in the list might be their age, they're 40. The third item in the list might be their vital measurements, and that in itself is a list containing 28, 34 and 29. And the last item may well be their height, 1.652 meters, so a float. So when we create lists, just remember that lists are very flexible. You can have any items you want within a list, including a list within a list. Now, we're not going to talk about that in any great detail on this particular course, but bear in mind lists within lists are in fact very useful and flexible ways to represent kind of 2-dimensional grids, arrays, such as a Sudoku board or a noughts and crosses board, crossword, anything like that that looks like an array, 2D array. We might also use it, as we've done in this case, to store within a person, which in itself is a list, some item that we want to know their vital measurements, which are a sublist of that. If we want to do that, then just bear in mind, again, we're not going to talk about it anymore in this course, but I just wanted to put it in here for completeness. If we want to index an item of a list within a list, we use this kind of double square bracket notation. So just be aware of that if you go down that route. Okay, so what can we do with our list? So here you go, we've created our list: pupils, George, Ahmed, Frida and Zita. And if we print pupils, we'll obviously get the list of pupils. Now I encourage you to stop the presentation and actually just go and do this now in idle so you can see what goes on. You should see it prints a list of pupils. You should see it prints the square brackets as well, because it's printing a list. Pupils is a list. So if you ask it to print pupils, you get the list construction. So you get the square brackets, you get the commas. It's probably changed your double quotes to single quotes. That doesn't matter, they're still strings. If we want to know what type of variable pupils is, we can say print type of pupils. And again, if you do that, what you should see is it returns a class of list. Again, don't worry about the class at this stage. It's a list, so it's showing you it's a new data type, one we've not come across before. So we can print the whole list. Well, that's not particularly exciting. Obviously, what do we want to do? Well, the same as we did with strings. Obviously, what we expect to be able to do is to index our particular list. So pupils, as we've explained, is a list. It's got these 4 elements in it: George, Ahmed, Fred and Zita. We know they're stored in memory somehow, don't know how. But the first item in the list is George, the second is Ahmed, third is Fred and the last is Zita. As we know from strings, we don't index the first item as 1, we index it as 0. Again, it's because of the way the memory allocation works. Pupils points to the first element in the list, so the offset to the first element is 0. Pupils plus 0 brings me to George. So we've just got to remember that, just like we did with strings when we were working with lists. And it should come as no surprise, therefore, that we can quite happily print pupils square brackets too. Now again, notice the square brackets here. These are the same square brackets that we were using when we were indexing strings, and they're the same square brackets we use when we create a list. But in this particular instance, we're using the square brackets to what we call index a list, which is get to a particular element within the list. So we're saying pupils 2, which obviously will go to item 2 within the list, which in this case is Frida, and that should print out Frida. And obviously we can print out any of the other elements in the list. What do we want to do? Well, again, just like we did with strings, we want to be able to iterate through our list. So we want to be able to go through our list, picking out each element one at a time. And how do we do that? Exactly the same way we did for strings. First of all, we need to find out how long our list is. So we use the function len. So we call the function len, we pass it pupils as an argument, so it gets a reference to the list. It goes and counts how many items are in the list, and it returns that, in this case, into our variable called list length. So list length now will be 4 in this case. We then go round a loop for indexing range 0 to 4. We know that actually only goes up to 3. Remember, it always goes 1 less. Remember, index is our loop variable, so index will take on the value 0, then 1, then 2, and then 3. And what are we doing within the loop, which is our indented print statement? We're printing the value index, and then we're printing the text index and then the value of index, just so we can see our loop variable. We're printing item, and then we're indexing the list with pupils brackets index. So first it'll be pupil 0, and it'll pull out George, then pupil 1, pull out Ahmed, and so on. So that's pretty straightforward. If we just want to see that one in action, so here it is. We've got our pupils, George, Ahmed, Fred and Zita, just like we had. List length, len pupils. For indexing range 0 to list length, print index, index item. I've called it item, that's probably not good. Children are not items, they are pupils. So I would say call that pupils. So let's just run that and see what it does. Okay, and as we expected, it's gone round our loop 4 times with the values 0 through 3, y up to 3, because our list length was 4, so list length here is 4, and for loops always go to 1 less than the end, so that's why it goes 0 to 3. And each time around the loop I'm printing the text index and the value of index, so you can see there it's going at 1, 2 and 3, and then we're indexing out that particular value from the list. So pupils 0 was George, 1 Ahmed, 2. Okay, and we call this again iterating through the list. Okay, pretty straightforward. So again, we've done that with strings, so now we've done that with lists. You can see there's a huge amount of similarities there. What else can we do? Well, we can also iterate through a list without using the index. If I'm not actually bothered where the item is in the list, a list itself is iterable. So here we go, we've got the syntax for pupil in pupils. It's a for loop. Pupil is the loop variable. Pupil will take on each value out of this iterable list that's at the end. Remember, normally you've seen a range command there, which generates an iterable list of increasing numbers. We've seen a string there, because we know that's a sequential set of characters. Now you're seeing a list here, and a list is a sequential set of items in the list. So we're going from pupil, for pupil, in pupils. So the first time round the list, from the list of pupils, it will pick out George, then it will pick out Ahmed, then Frida, and then Zita. And we just print the pupil that time. And again, we say, just to try and reinforce the terminology here, we're iterating through the list. So any list, in this case pupils, is iterable. It means we can go through it one stage at a time. Again, if you just wanted to see that in action, we'll go back to our bit of code we had before. There's our loop. Now we're going to, I could leave it as index, but it doesn't make sense because now the items we get out not there are our pupils in this case. So for for pupil in pupils, and obviously we've got no index to print this time because we don't know where we are in the list. Python is taking care of that. Pupils, and obviously I don't index the list now. I just print the loop variable, which is pupil. Let's run that. And hey presto, pupil, George, Ahmed, Fred and Zita. It's been great because I've not had to worry about where the end of the list is. I've not had to worry about the position within the list. I've just iterated through the list. Again, that's something that Python does for us, which is very good. Excellent. So, where do we go from there? Well, again, there's more similarities with strings. We can slice up lists in the same way that we can slice up a string. So here we've got our list of pupils we've been looking at, and we could go and print pupils 0, 2. So ask yourself what you think that would print. Give it a go in idle, and hopefully you'll come back and discover that it printed George and Ahmed. It didn't print Frida, even though Frida's at position 2, because just like strings, you don't print up to the last position in a range like that. Just like a for loop, you don't go to the last position in the actual iterative list of numbers. So here 0 to 2 gets us from 0 to 1, which is just George and Ahmed. What else can we do? Well, we can certainly add lists together. So remember this plus sign that we've looked at before, we're now discovering it's even more useful than we realized. Plus by itself with integers either side or floats will add them together numerically. We know if we've got a string either side of a plus sign, it will concatenate them together. And here we've got two lists either side of a plus sign, and again Python will just sort it out and concatenate them together. So what would this do? It would print pupil 0, 2, sorry, it wouldn't print, it would work out pupil 0, 2, which we've discovered is George and Ahmed, and it would concatenate that with the list pupil 3 to the end, which is Zita. So that's just to the end. Here's a good question for you though. What would this particular statement down the bottom do? print pupils 02 plus pupils 3. So we're just extracting zeta at this stage. Now you might be tempted to say, well, obviously we just add zeta onto the end of the list, but you need to think about it a bit more carefully. Think about what pupils 02 is. Pupils 02 is a list of 2 pupils. Whereas pupils 3 is not a list, but is the item out of the list, and so is a string. Here we're trying to add a list to a string, and surprisingly enough, it will fail. And here's our code in action. So we've got our list pupils George, Ahmed, Fred and Zeta. We're extracting 0 to 2, which we know is George and Ahmed, plus pupils 3 to the end, which we know is Zeta to the end. Both of these are lists, so we can add them together, concatenate them and print our new list. Let's just run that. Yeah, George, Ahmed and Zeta, as we expected. However, if we change this and we do 3 colon, we're now not getting a list from here because pupil 3 isn't a list. Pupil 3 is just the item zeta. The item zeta is just a string. So now we're trying to take a list and add a string to it. Let's see what happens. There we go. Can only concatenate lists, not strings to lists. That's exactly what we just said. So what happens when we want to add an item to the end of a list, because it's a legitimate thing to do? Well, there's a particular way to do that. It's using what we call a method. So basically it's a function already associated with list types. So here's how we do this. We've got our list, in this case I've called it letters. It's got the letters S and T in there, printed out. What we then do is we get the user to enter a letter, input new character, and I want to put whatever new character that they typed in onto the end of my list, which has already got S and T in there. So to do that I use this append method. Now it's a function effectively because it's got the brackets after it, append, 2 brackets, and I'm passing in the new character, the one I actually want to add on. But because of this dot notation, it's now what we call a method. It's a method and it's associated with lists. So we can put the dot after the description of a list, in this case letters. And what does it do? It means to the list specified before the dot, I want to append whatever's in the brackets afterwards. Pretty obvious really. So whatever letters typed in is appended to the end of letters. Now a subtle point here is it actually changes the list letters. The append function here doesn't create a new list and we've got to then put that back into the list letters like we do in other cases. Here it actually appends the list directly, so there's no association of having to reassign it somewhere, and then we just print the letters out. So that's how the append function works. So here's our bit of code in action. Here are our letters S and T, which make our list. We print them out, we ask the user to put in a new letter, and then we append that letter to the end of our list called letters and just reprint it. So let's just look and confirm ourselves that it does run. So there's our list S and T. It's asked me to enter a letter, so I'm going to add a D, and it reprints the list now. You can see with a D added on the end, so it's appended it. Now it feels quite innocuous this, and you kind of get this straight away, but there's an important thinking point here that you might have skipped over, or it might come and catch you out later on. So I just really want to reiterate it here. Letters is a list. Lists are mutable, which means when we call the append method on the list, we actually, to the list, to the actual list letters, we add the whatever letter it was bang on the end. So we've altered the list directly. We don't have to now do this. We don't have to generate the new list over here with saying append and then reassign it back to the variable letters over here. We do that in lots of other cases if you think about it. If I said x plus 1, you wouldn't think, well obviously that just adds 1 to the value x. We're also used now to doing the x equals x plus 1 because we know we do the calculation here and then we reassign the value of the calculation back to the original variable. We do that because in Python these are immutable. We can't change x, so we reassign it to a new variable x and move the label. With strings it's different. With strings we've got letters and we can change the string directly by appending it on the end. So having done the new calculation here, that's it. We don't have to reassign it back to letters. It's already altered letters. So that actually reassigns our string. And that's got important consequences when we look at passing strings into lists, which we'll look at later. Okay, so that's how we use the append method. What else can we do? So the slides here actually just explain that. I've forgotten to actually put a slide in. The letters explain this is what we do, and we don't do what's at the bottom there, which we've just been through. What else can we do with lists? Well, we can call a method on a list called sort, and this will sort our letter out for us, sort our list out for us. Now clearly if the items in our list are just strings, it will sort them out for us alphabetically. If they are just numbers, it will sort them out numerically. If they're mixes of things, then it's a bit indeterminate what's going to happen. I'm sure there are rules about it, but I have no idea what they are. And it doesn't make sense to sort a list of random things. So how do we do that? Well, again, what we do is we call the letters.sort method. And you can see here we've called the sort method on letters. That will have altered letters, and then that's forming part of our print statement, so then we print it all sorted out. So let's just have a look at that code. So we print our letters and then we'll print letters dot sort. Run that bit of code. So I'll enter a letter, I'll do an A because that goes at the start. Oh. Okay, yeah. So what's going on here? It's printed none. So why is this printed none? We've printed letters.sort. Well, remember when we call a method, what we do is it returns a value for us. And it's the return value that we print. Well, we're not actually, in this case, wanting to print the return of letters.sort, because letters.sort sorts our letters out for us. So we want to print, after having called the method, we just want to reprint letters. So what do? We call the method letters.sort, that sort them out, and we just reprint them again, saying print letters. Here we go, put an A in at the start. STA, it sorts them and does AST. Okay, so just reiterating that again. So letters.sort actually goes and sorts them, but the return value of that function call there, or that method call, isn't the actual sorted letters. It's still it's a non-value because it's just sorted them out for us. The actual sorted values are in the string letters, which is why we can just print them out at the end. Okay, and in fact now we've answered the questions that appear here. What does letters.sort do? It actually sorts the letters. And what does letters.sort return? It actually returns a non-value, because its job is to sort the letters, not return the sorted letters. They are just sorted within the string anyway. So again, it illustrates that lists are mutable and we can change them. Let's just further try and emphasize that by going back to do something that we did right at the start of our look at Python, looking at what we call the idea of a function. So if you remember what the idea of a function is, the idea is effectively where it is stored in memory. It's a reference to the object, which is where the information is stored. So what we do here is we've got our pupils list again. We print pupils. We print the ID of pupils, which shows me where the list is stored in memory. We then go in and we do pupils brackets 2 equals Frederick. So we're altering an item within a list. Now if you remember, when we did this with a string, it wouldn't let us do it because strings are immutable. We can't change them. But when we do it with a list, we can quite happily change Frida to Frederick. And if you print the pupils out, you'll see it's changed. And if you print the ID out, again, you'll see that it's still the same ID, so it's still the same list. And reiterating again, as we did with letters, when we change the list, as we've done in this case, that's it. We've just changed the list. We don't have to reassign it back to the original variable. Remember, we had all that difficulty with strings where we had to slice it up and rebuild a string and reassign it back to the same variable. Don't do that with lists because they're mutable. So, what's the impact of this? And if anything, this is the crux of this whole discussion on mutability and immutability. It's getting your mind around why does Python work like this when we start passing lists around. So, slight aside now, I want you to think about, imagine you're writing a shopping list program and you're just going to maintain a list and you want to add items to the list as you think about other things that you want to go and buy. So let's think about what you'd do. You'd write a function to add the new item. You'd pass in the list that you wanted to add the item to. You'd pass in the item that you wanted adding to the list. And you'd call the append method because we know the append method works. So we append the item to the list. So you're inside the function now, and you've now got your new list. In this case it's called a list, and it's got the extra item on the end. The question is, do you have to return that list back to the main function or not? So we've put it here in red because obviously we're questioning whether that is needed or not. And just for a note, obviously that this is a wrong code, so if you actually come back and glance at this slide, I don't want you taking this away as a way to do it. Okay, so here's the code we'd be tempted to write. Again, remember this is not the right way to do it. It's an illustration. We've got our shopping list. We create our list of 3 items. We print it. We create a new item called bread, which is a string, and then we call our function add new item, and we pass it the shopping list, and we pass it new item. So remember, it doesn't pass the variable name itself, but it passes what these are pointing to. So it points, shopping list is pointing to this list of milk, eggs and sugar. So that pointer is now passed to a list. So a list is now pointing to milk, eggs and sugar. And the new item is pointing to bread. So item now points to bread. We run our function which appends obviously bread to our list. So a list now within the function has got milk, eggs, sugar and bread, and in this case we're returning the list out because we've altered it. We return it out, and when we return it out we assign it back to a list. Assign it back to a list, sorry, that should be shopping list. We assign it back to shopping list and reprint the shopping list. So let's see if that actually works for us. Yep, seems to work. Milk, eggs, sugar and bread. So you feel you've coded that right, and it all makes sense because we're in a function here. We've altered something in the function, and we know stuff within a function is only locally relevant. Therefore, if we want to pass something back out, we return it out as an a list. But let's just have a think about what's going on within that actual function. So here's our def main. Here we create shopping list, milk, eggs and sugar, and we know what that does. It creates a label shopping list which points down to somewhere in memory milk, eggs and sugar, and they're stored as a list. We create a new item which is bread. So new item is a label which points to a string variable bread. So we've got our list variable and our string variable. What do we do next? Well, next we call the function add new item, and we pass in shopping list and new item. And here's our definition of our add new item function. So as we call the function, remember what happens. Here it is in main, add new item, shopping list. So the reference for shopping list, which is this reference down here pointing to this list, the reference is passed into the function. Inside the function we've got a local variable called a list, and that gets a reference to shopping list. So a list over here now points to list, as it does with any variable when we pass it in. We don't copy the variables in, even though that's what we say we're doing. What happens with new item? Well, new item up in main, we've said new item points to bread. We pass in the reference from new item into a variable called item. Again, item now is a local variable to our function, and again, item points to that same location, bread. So within our function, a list and item are local variables, but at the moment they're still pointing to the main areas in memory. What do we then do? We issue the command alist.append item. So we're in the function here, so a list, this is our list, this one over here, and we want to append item. Item is bread, and we append it to whatever a list is pointing to. Now remember, lists are mutable. Other objects are not mutable, and because a list is mutable, we are pointing at a list and we've been told to append an item to that list. So we do that. We just go and stick that item on the end of our list. So what happens? Bread is appended onto the end of the list. We haven't created a copy of the list within our function like we do with other variables. If we messed with item at this stage, we changed item, not that it makes sense to do so, but if we did change item, because a string is immutable, we can't change that. So then we would create a local copy inside the function, and that would have some new value in it, and we wouldn't have altered the one outside. In the case of a list, we've altered the actual list itself, which means when we get to the end here, we don't need to return it, because clearly as the function ends and these labels go, well, the list is still the same list with bread added. We haven't made a new list. So shopping list now points still to the new list. Well, it's the same list, but just with bread added. We haven't made a new list because lists are mutable. We can just change them, and we've just added bread onto the end. So it means that we don't need to put that return function there. So this is our actual code that works. And if we just go and look at that back in our main function, it means now we don't need to return list there. And it means that when it returns, it doesn't return anything into shopping list because it's altered the actual shopping list. And just to prove to you that works, run module. There we go, milk, eggs, sugar, and bread. So clearly our function in here has altered the list, which a list pointed to when you were in the function, and from main shopping list pointed to it, and we've just changed the list. So that is probably one of the most crucial points of passing lists into functions. They're not like strings or ints or floats or bools, where if you pass them in and you then change them, you've got to pass them back out if you need that value. With lists, you just pass the reference to the list in, and if the function changes what's in the list, well, it's changed it in the list back in main as well. Okay, really crucial point there. So that's the way we do that. So how does this help us back in our Hangman program? Well, what we need to do now is go back to our Hangman program and think about how lists are going to help us in the design of that, so that we can pass information into our functions referring to lists of items. Okay, so back here with our Hangman function, remember where we were. We'd set up a word, we were looking for a particular letter in the word, we set up our current guess, which is obviously blank. We'd written the find character function, which went and looked for a particular letter in the word, and when it found it, it returned that position. And then we'd written the function called place character in, so given a letter and given a position, it put it there within our guess. So it was slowly building up our word. So just run that, make sure we're all happy with what that does. So there we go, we got the word reality, we were indexing through reality. When we got to the Y, we found that the Y was at position 6, and then we called the function to put a Y at position 6 in our guess, and there it's done that. So if you remember what the problems were that we had identified with this program early on, if I do the word televisions, obviously now I need to make this a bit longer, so that's the same length as my televisions, and I'm looking for the letter E in televisions. I can see that there's an E here in position 1, 2 and a position 3, so it's in 2 positions, but because of the way I've written my code, when I actually run it, I only find it at position 1. And if you think about it, well, it's just because we didn't think enough about our code at this stage. When we were writing this, we just thought about finding a letter, and that was it. Obviously what we need to do now is think about finding, well, 1 letter or 2 letters, or indeed no letters. Obviously that was the other option that we said was a problem. If not a V. If I try and search for an X in televisions, what happened there? You might remember this from one of the earlier presentations. It said an X was found at position 10, which was obviously a lie, and if you look what it's done in the window there, it's actually then gone and stuffed an X right at the end for us. So it kind of got to the end, it broke out of it ended the loop anyway. The index value was 10, which was 1 past the end, and it said, oh, well, I found an X there. Again, within our code here to find a character, we didn't think about what would happen if we didn't find a letter. We were so focused on finding letters. So from our knowledge of lists now, hopefully you get the idea that probably what we need to do here is generate a list of all the places that we find this particular letter. And when we're building our list, we need a list to start with, so that as we find the letter at a particular position, we can add on to the end of that list the new position we found it at. So the way we tend to do something like this is we create ourselves a list in here, maybe called locations, and we set it up as an empty list initially. So this is our empty list. Now what we do is when we find the letter at a particular position, we don't break out of the loop, we want to stay in the loop, but what we do want to do is do locations dot append, and we want to append our index. Okay. Now again, notice because the lists are mutable, we've just changed the list locations. We don't have to reallocate it back into locations. And at the end, because we created the list within our function, in this particular case, because there was no list before this locations here, we do actually need to return it out of the function. So in this particular case, we're going to return it out of our function. Okay, so let's just see what messed up my code there a little bit. Let's just see what that does so we can get an understanding on what's going on. So after we've called our function here, find characters, now at the moment it's returning locations, which is going to get into a variable called position, but I'm going to call it positions now because there's more than one position, and I'm going to say letter found at positions. The variable is now called positions. I'm not going to start trying to add it into our guess at the moment. We're going to look at that bit in a moment. So I'm just going to comment those two out. So let's look what happens at the moment. So we'll leave it with an X, see what happens with the X, looking for X in televisions. So it went all the way down through televisions and it said letter X found at positions, and it's returned the empty list. Well, that's what we'd expect it to do. The list started empty, it didn't find a match anywhere, so it didn't append anything on, and it's returned an empty list. So that's quite good. It's got round what we do about ones that don't match. If I search for my L, because there's one L in there, let's see what that does. Here we go, so T-E-L-E-V, and it found the L at position 2, which is correct. 1, 0, 1, 2. So it's found the L and there's no more L's. Notice it's not returned just a number 2, it's returned the number 2 in a list. This list has only got one item in and it's the number 2. What happened if we search for an E? So we're searching for E in televisions now. Let's run our code again. And here we go, it's found it at 1, 3. So it's found it at position 1, that's that one there, 2, 3, and it's found it at that position. So it's found it in multiple locations. Brilliant. So you can see our function now is making use of lists by returning a list of all the possible locations. Okay, so back up in main here now, positions is obviously a list. So when we come to place our letter in list, what have we got to do? Well, obviously now we pass in letter, but now we pass in positions. Positions is a list. Okay, so down here in place character in, I'm going to rename this positions. So it's got the same name, not that it matters. And think about what I want to do now. Imagine the E that we just talked about. The E was found at locations 1 and 3. So I need to execute this line in with pos being 3 and pos being 1. Sorry, the other order. Pos being 1 first and then pos being 3. Because I need to put the E in at position 1. So I need to call this with pos being 1. And then I need to put the E in at position 3. In fact, I need to do this for every item that's in our list. So I need to iterate through our list. And how do I iterate through a list? Using a for loop. So for pos in positions. That needs to obviously be indented now. And for each of those positions, so imagining again it was the E, we'd come down here and pos would take up the value 1 and it would call this line here with pos being 1 and it would replace the E at position 1. And then we go back round the loop and now pos would take up the second value in our list, which is a 3, and it would rerun this line now with pos being 3 and it would put in at position 3. So let's see if that works. There you go. E is found at positions 1 and 3, and you can see it's put an E in at positions 1 and at position 3. Again, let's just check that that doesn't mess up if it's something that we can't find, such as a Y. Okay, so found at null positions, and the guess is nothing. How did that work? Well, positions that got generated, locations that got generated here was a null list, an empty list that got put into positions. We passed the positions with nothing in it down to our place character in. So this had nothing in it. So when we iterated through here, it didn't go at all because pos couldn't take any values on because there was nothing in there. So it didn't run the command and just return guess back out. So it didn't alter it at all, which is really neat because it means I've not had to write a special case now for when our list is empty. The software is just taking care of it for us. Fantastic. So that's kind of how we use lists within the context of our Hangman program. So we've now gone and looked at how we apply lists to the Hangman program. And that's it. Thanks very much. Bye.